Now we are going to graph a quadratic in vertex form. We have learned from the previous lesson how to find the vertex. We know that our vertex is the opposite our h value and our k value. We don't have an a value in this case, so our vertex is going to be positive 2, positive 3. So we are going to graph that point on this graph. So go to Menu, Geometry, Points and Lines, Point. So we are going to put positive 2, positive 3 on our graph, and that should be our vertex. Since we don't have an a value, our graph is going to be the same size as the parent function. And we know that our parent function goes over 1 and up 1 for our next point. And it is symmetric, so we go the other way. -1, up 1, and it goes through that triangle right there. So this should be our graph of this equation. So we are going to check it. We will put our equation in and see if it goes through those points. And it goes through all 3 points, so that is the graph. So now if we look at this one, we have a negative in front of our x squared, so that means that our equation is going to open down. So our vertex in this case is -3, -1. So we want to start off by graphing that. So -3 and -1. So there is our vertex, and it opens down, but it is still the same size as the parent function, so we know we're going to go over 1, and we're going to go down 1 since it opens down, and the same thing on the other side, over 1, down 1. So those should be the first 3 points that our equation goes through. So here is our equation, so we'll enter. So there it is, and it goes through our 3 points. Now in this one, we do have an a value. So we're going to start off by graphing our vertex, which will be -4, -2. So -4, -2. There is our vertex. Now to find our other point, it's going to be, since our a value is 1/2, that's between 0 and 1, that means it's going to be wider than our parent function. So our parent function would go over 1 and up 1, but ours is going to be wider than that, so it's going to be down here somewhere. So instead of going over 1, up 1, we have to multiply that y value by 1/2. So 1 times 1/2 is 1/2. So over 1 and up 1/2 of the way. Now we may not be exact here, we're just gonna do our best. And the same thing on this side, over 1 and up 1/2. So then we'll check to see if our function goes through those points. And there it does. Now on our next one, now we don't have all 3 transformations on this one. We don't even have a k value. So when we're finding the vertex and we don't have both an h or k, whatever we don't have will be a 0. So this one means it moves over +1 to the right, but it does not move up or down. So our k value, or our y value, will be 0. So our vertex in this case is +1, 0. So we're going to graph that. So +1, 0. So there is our point. Now, it does not have an a value, so it's going to go over 1 and up 1, just like the parent function, and over 1, up 1. So there is our function, and it goes through our 3 points. So here on this one, we are missing the h value. If we do not have parentheses in our vertex form equation, our x value of our vertex is going to be 0. Our k value is 1, which is our y value. So our vertex in this situation is 0, 1. It moves the graph up 1. So let's go ahead and graph that vertex. So 0, 1. Now we do have an a value, and our a value is also negative. So it's going to open down, and our a value is 2, which is going to make the quadratic thinner than the parent function. So instead of going over 1 and down 1 like the parent function will, we have to multiply our y value by 2. So 1 times 2 is 2, so over 1 and down 1, 2. And let's try that again. So let's go over 1 and down 2. It does not want to do that. So one more time, there's our vertex. Let's go over 1, down 2 this way. And over 1 and down 2, let's get off that 1 right there. There we go. So now we have our 3 points. So let's make sure that our equation goes through there. There is our equation. So let's enter. And our equation goes through those 3 points. So that is how you graph using the vertex form.